What would it be a good idea for us to expect when a huge, very Goliath star detonates in our area? The James Webb Telescope's new disclosure about the Betelgeuse cosmic explosion is giving researchers reason to worry that we might have been extremely off-base about the red monster star. Does this imply that we on Earth will, before long, need to deal with the blast and its impacts? The James Webb Space Telescope has shown us a few times lately that our researchers might be off-base on account of a cosmic explosion. Such a mistake could have deadly outcomes. Betelgeuse is a red supergiant star. For quite a long time, the star has been noticeable in a conspicuous position in Orion's shoulder. It sparkles red, which we can see with the unaided eye on Earth. One thing is sure, Betelgeuse will detonate, and soon. On an inestimable scale, it will happen at some point among now and a few years from this point. Since Betelgeuse has been acting increasingly unusually, researchers have been discussing what is right and where gigantic mistakes might have sneaked in. Is Betelgeuse currently on the way to a cosmic explosion? Or is the maturing star simply having a temporary bout of instability? In 2019 and 2020, abnormal obscurations occurred, leading some researchers to guess that the star was going to detonate. Others dismissed it, saying that these events had nothing to do with the star's actual condition. So what is valid? Betelgeuse is a colossal star that surpasses our Sun by a factor of 1,000. If we somehow manage to put it in the center of our solar system, it would extend past the orbit of Jupiter. Betelgeuse was not always so huge. It has only expanded since it spent its fuel supply. This development in size is due to the dynamic exhaustion of its fuel supply in its core. The star fuses hydrogen into helium and later into heavier elements. When the hydrogen in the core is spent, the star begins to shed off its outer shells, leading to an increase in its diameter and variations in brightness. So how do we figure out what stage the star is in? On one hand, our observations allude to data from other supernovae, but this has its complications as these events are extremely rare. Thanks to telescopes, we can now observe supernovae in different galaxies or other corners of our own galaxy. However, like the case with Betelgeuse, no two are the same. Is Betelgeuse risky for Earth? Did you know that Betelgeuse could have already detonated and we haven't noticed? Because the star is around 700 light-years from us, this means its light takes 700 years to reach us. If the star detonated, we wouldn't see it until 700 years later. Supernovae release huge amounts of matter into space and produce radiation that can be destructive. However, despite the violence of these events, the fact that none of them affects us assures researchers that these blasts will not reach us. Still, we are not entirely unaffected. Violent bits of matter, such as burning fragments or dense gas, are lost over the distance of 700 light-years. There are other particles and radiations for which this distance is practically insignificant. These include neutrinos, which could be with us before we even see the light. Neutrinos are somewhat newly discovered particles in astronomy, also known as ghost particles. Because they easily pass through matter, neutrinos are all around us in nature and in the universe, but we know very little about them. We have only been detecting neutrinos for a few years using specialized facilities in Japan and Italy, among other places. However, Betelgeuse shows us something that can be concerning. We are far from knowing all the different particles, radiations, and phenomena. It is exceedingly rare for a supernova to have detonated right in our cosmic neighborhood. It is therefore important for us to understand what else will be thrown up by such an event. Another complication is that we don't know for sure how far away Betelgeuse really is from us. Measurements of the distance between Earth and the red monster star have consistently produced slightly different results, and all astrophysical measurement techniques are currently under review. The old physics has had its day, and some startling observations by the James Webb Space Telescope are responsible for this, showing us how often they are incorrect. What if such a mistake is also present in the assessment of the situation around Betelgeuse, and we are in danger? After all, researchers are debating whether it is going to detonate or not. It is intriguing, or even alarming, how differently researchers view the behavior of Betelgeuse. The extreme obscurations of 2019 and 2020 were eventually explained by a massive eruption from Betelgeuse's surface into the universe, creating a dense haze of dust that obscured the star for a long time. We are familiar with such phenomena from the Sun, but coronal mass ejections from our Sun are much smaller and don't usually produce such massive clouds. Our Sun is also still a star in its midlife, whereas Betelgeuse is a mature star. Some researchers have compared Betelgeuse's eruption to an elderly person's cough. Betelgeuse required years to recover from this event, and some believe that such unusual events could mean the star's end might come sooner than expected. It is normal for Betelgeuse to dim. The star has two well-studied cycles within which it operates. However, the 2019 event and the subsequent 2020 obscuration occurred outside these cycles. It is thought that there might be a third cycle spanning several thousand years that we had little knowledge of until recently. Nonetheless, we should not expect that everything in the universe is always predictable. In this respect, the thoughts of our researchers are confirmed. We should always expect surprises, and Betelgeuse could detonate a lot earlier than expected. The most widely accepted estimates right now predict an explosion within the next 1,000 to 100,000 years. In this context, however, recognize that this does not mean it will definitely happen. A Japanese team of researchers presented a valid and well-researched study that caused a stir in the scientific world. According to the study, the disturbances on Betelgeuse's surface could be interpreted in a completely different way, and the likelihood of an explosion could be significantly shortened. This group argued that the unusual behavior of massive stars like Betelgeuse could be evidence of rapid processes in the final stages. Betelgeuse's core collapse would be inevitable. Betelgeuse becomes heavier and heavier and hypothetically collapses. We know well how a star works theoretically. Betelgeuse was once possibly a huge star that began its life as a hot, primordial star. In such a star, nuclear cycles occur in which hydrogen first fuses into helium. This fusion releases tremendous amounts of energy that keep the star stable for millions or billions of years and prevent it from gravitational collapse. Eventually, the hydrogen supply in the core is exhausted, and the star starts to fuse heavier elements. During each of these stages, the star continues to expand as the energy from fusion pushes the outer layers of the star outward. Betelgeuse is in this stage and has become a red supergiant. This expansion is a clear sign that the star has largely depleted its fuel reserves in the core. The critical point in the evolution of a massive star like Betelgeuse is the end of fusion. When the core is composed mainly of iron, no more energy can be produced through fusion. Iron fusion consumes more energy than it releases, which is why the fusion process stops. Without energy production through fusion, the star loses its balance. The gravitational pressure, which was previously balanced by the energy from fusion, then leads to a collapse of the core. Within minutes, the core implodes under its own gravity, reaching extreme density and temperatures. This collapse creates a shock wave that races through the star and ejects the outer layers into space at tremendous rates. This is the supernova explosion. When a supernova detonates, an unimaginable amount of energy is released, making the star shine brighter for a few seconds. The energy released exceeds the total energy produced by our Sun over its entire lifetime. The outer layers of the star are flung into space. What remains is the core. The star can either further collapse into a neutron star or, in the case of even more massive stars, a black hole. A neutron star is an incredibly dense object in which matter is compressed so much that protons and electrons combine to form neutrons. Such a star has extraordinarily high density. If the remnant is even more massive, it collapses further into a black hole, a region of space from which not even light can escape. The exact nature of the remnant depends on the original mass of the star and the details of the explosion. The glorious death of Betelgeuse will be an amazing galactic event and will provide us with significant insights into the processes at the end of the lives of massive stars. It will mark the end of an era for one of the most famous stars in the night sky and signal the beginning of a new stage in the study of supernova physics. Find many more fascinating videos on the channel. Now, Betelgeuse, one of the brightest stars visible to the naked eye in the constellation Orion, has fascinated astronomers and stargazers alike for years. Its distinctive red hue and prominent position have made it a celestial icon. However, its evolutionary journey holds even greater scientific interest. Located about 700 light-years from Earth, Betelgeuse is classified as a red supergiant, a stage in the life cycle of massive stars characterized by its enormous size and unstable nature. This celestial giant has expanded to such an extent that, if placed at the center of our solar system, it would engulf the orbits of Mercury, Venus, Earth, and Mars, extending even beyond Jupiter's orbit. This immense size highlights the colossal scale of Betelgeuse and its massive mass compared to our Sun. Betelgeuse wasn't always the behemoth it is today. Like all stars, its existence began in a fiery dance of nuclear fusion within its core, born from vast clouds of gas and dust. The star ignited into a blazing sphere where hydrogen atoms fused, producing energy in the process. This fusion process, known as stellar nucleosynthesis, transformed hydrogen into helium, powering Betelgeuse's brilliance and supporting its balance against the relentless force of gravity. However, stars like Betelgeuse are voracious consumers of their nuclear fuel. Over millions of years, the hydrogen in its core began to deplete, leading to a series of nuclear reactions that altered Betelgeuse's internal structure. As hydrogen fusion waned, helium became the primary fuel source, fusing into progressively heavier elements like carbon, oxygen, and silicon. Each successive fusion stage produced less energy and lasted for shorter periods, contributing to the star's evolutionary instability. The depletion of hydrogen marked a critical turning point in Betelgeuse's life. With its core now composed primarily of inert helium, the star's internal dynamics shifted dramatically. The core's inability to sustain fusion reactions meant it could no longer produce sufficient energy to counteract the internal gravitational force. This gravitational collapse initiated a series of events that would ultimately lead to Betelgeuse's spectacular demise: a supernova explosion. Supernovae are immense eruptions of unimaginable power. When a massive star like Betelgeuse exhausts its nuclear fuel, the core collapses under its own gravity with staggering force. This collapse triggers a colossal explosion, propelling the star's outer layers into space at speeds exceeding thousands of kilometers per hour. The resulting blast can momentarily outshine an entire galaxy, emitting more energy in mere minutes than our Sun will produce over its entire lifetime. For astronomers, the prospect of observing Betelgeuse's supernova presents a unique opportunity to study these cataclysmic events up close. Supernovae are crucial to our understanding of the universe's composition, as they disperse heavy elements forged in their cores across the cosmos. These elements, vital for the formation of planets, stars, and even life itself, are scattered into interstellar space, where they eventually coalesce into new celestial bodies. The outcome of a supernova is similarly significant. Depending on its mass, Betelgeuse's remnant could form a neutron star or collapse further into a black hole, a region of space so gravitationally intense that not even light can escape. Neutron stars, formed from the cores of massive stars, possess densities so extreme that a single teaspoon of their material would weigh billions of tons on Earth. These remnants serve as vast laboratories for testing the limits of physics under conditions impossible to replicate on Earth. Despite Betelgeuse's astronomical importance and the scientific wealth it promises, its potential to impact Earth remains negligible due to its vast distance. Light from Betelgeuse takes approximately 700 years to reach us, meaning that any explosion observed today actually occurred centuries ago. This enormous distance ensures that the radiation and debris from Betelgeuse's supernova, while immense in cosmic terms, pose no immediate threat to our planet or solar system. Yet, the journey to understanding Betelgeuse's fate is fraught with uncertainty. Astronomers' ability to predict when Betelgeuse will detonate is limited, as supernovae are rare and their timing unpredictable. Recent observations have shown variations in Betelgeuse's brightness and surface characteristics, leading to speculation about an imminent explosion. However, these variations could also indicate transient phenomena within the star's complex environment, challenging researchers to distinguish routine stellar activity from signs of an impending eruption. The James Webb Space Telescope, set to be the most advanced space